going to learn about product rule. Why do we need product rule? To differentiate this thing. Why is it necessary? Because it's so difficult to expand. By the time you finish expanding, that's one page. It's just too long, right? So we need some rule to differentiate this thing. And furthermore, what if you have to do this? You can't even expand. How do I differentiate this? So to answer these questions, we have to get a rule. And to do that, we do some investigation. I'm sure some of you know that rule already. Some of you, if you read ahead, but let's go through. Let's do some investigation. So we're going to expand this. So if we expand, we get 3x plus 2, right? How do I get 3 so quickly? 1 plus 2 is 3. 1 times 2 is 2. Right, we're going to expand this and then find the derivative, which is easy to do. And then now we're going to call the first thing u, that thing v. So your u is x plus 1, v is x plus 2. And find the derivative, which is 1 and 1 respectively. Pretty straightforward. Okay, can you do the same as the other one and see if we can find some connection? Quick, sit down. Yep, they have to. No, sit down. All right, close the door. Hurry up. On page 29. Quick. All right, try the next one and see if we can find some pattern. So see if you can make any connection with the derivative and some of these stuff. Any connection. If you have found it, let me know by raising your hand. Any connection. Who want to have a try? Any connection? Again? Yes, from here, looks like you just have to add these two, right? It works. Now, let's see if it works for the next one. Let's see if it works. So you have to see over there, or I don't know. X squared plus 5x plus 6. Differentiate. Let's see if it works. So that's your u. That's your v. X plus 2, x plus 3. Looks like it works. Looks like I don't need the derivative. Looks like we can just add these two. Maybe. But we've got to be careful. Like when we do experiment, when we do science experiment, we have to, hurry up. We have to make sure you cover more cases, not just one case. So let's see whether it works for the other one. Okay, so let's expand these ones. Let's see if that works. I'm still recording, so if you miss, just ask your friend later or watch the video later. Okay, expand this 3x squared. So in here I'm going to write maybe. Maybe it's true, maybe not. Maybe the derivative of f is same as the u plus v. Maybe. Maybe you don't need to differentiate at all. Maybe, but let's see if it works. All right, 3x squared plus 3x plus x is 3x plus 1. Derivative is 4x plus 3. Now remember, your u is the first factor, u. Second factor is v. U is 2x plus 1. V is x plus 1. Differentiate 2 and 1. Now clearly, the one we hypothesized earlier doesn't work by adding just u and v. We probably have to involve these guys. Yes. That's right. Yes. So let's see if it works. So now somehow maybe if we times these two, let's say we times these two, times this, let's say u dash times u times itself. 2 times 2 is 4x plus 2. If I do u dash u plus u v dash, let's see if that works. X plus 1. It doesn't work, right? So we have to, so u dash, so we swap, right? We try different combination until it works. So maybe u dash the v, then u dash the uv dash. Would that work? So we do 2 times v is 2x plus 2 plus 2x plus 1. And it works for that. And then you ask, would it work for this guy? Well, let's try again. Let's try again. So 2x squared, 4x minus 5x minus 10 minus x minus 10 Okay, derivative is 4x minus 1. And u is 2x minus 5, x plus 2, 2 and 1. Whether it works, let's see whether it works. So try again. U dash v plus, I should have left more space. I'll make improvement in the next time. Let's try u dash v, u dash 2 times x plus 2, u2x minus 5 times 1. So we do have to involve the derivative. The other one doesn't, you don't need it because it's 1, right? 1 times anything is doesn't make a difference. So it seems that it doesn't involve it, but now it does involve. Okay, so let's time. So 2x plus 4 plus 2x minus 5. 4x minus 1. Oh, it works. So now we have a statement of the product rule that if f of x is equal to uv, or probably we just use y. Now, how do we state it in the reference sheet? On the reference sheet, they use this symbol. Okay, cool. Okay, if y equal to uv, yeah, that's what they did. They did y dash, actually, they use dy over dx equal to the v times the vx. Oh, I don't like how it's written in this thing. Okay, I'm going to write this v times du dx plus u times dv dx. Now, this is that's from the reference sheet. Reference sheet. Let me fix that. Yep. Okay. Or if I use this symbol, it's better. UV, just remember UV light, UV double UV, one on the U, one on the V. Notice that I insist you to write that first because later on when you learn the quotient rule, it's very similar. That if we keep the same order, that will be better. Okay, so because later on the quotient rule, you have to write the U dash V first. Otherwise, you'll get it wrong. So make sure you do that. So that's on the reference sheet. It's a bit hard to read using the dy over dx symbol, but this is easier. How do I remember? UV light. UV, right? UV again. So one on the U, one on the V. All right, product rule. Any question? Okay. On your textbook, there is a proof. When I was young, I'm obsessed with proof. But again, I don't think it's examinable, but it's good to know how to do it. I will just start you off. I won't do the whole thing. So the proof is just doing this. Y equal to UV, and what they did is they add delta. They add a little bit to the Y, and when Y change a little bit, so does the factors. The U and the V changes a little bit. Changes a little bit, and V changes a little bit, right? And then if you expand that, UV, right, delta U, delta V times U plus delta U times V plus delta U delta V, right? Okay, now the thing you need to know is Y is UV, so they kill each other, right? And then what you do is you're going to divide both sides by delta x. Why do I do that? Because I want to get the y dx, right? Delta x, delta x. And when you take the limit as delta x approaches 0, or maybe I'll just do the whole thing. I was planning to stop somewhere. All right, right? Equal to the limit as delta x on each of the things. Delta x. So you take the limit on each of these, yeah. So it gets a bit complicated. But if you read through the proof, if you're interested, some of you may like, oh, I want to go through the proof. So if I become a tutor one day, so a lot of people going into medicine, they still tutor maths in university to make ends meet, or they just want to buy a luxury item. So so it's like they pay a bit more than other jobs. So they say, they got a student who want to know why. Okay, they can prove it. You know what I mean? Yeah, just extra job. I remember I taught a student. She only did advanced maths. She's very good at it. She could have done extension too, but she only did advanced. She only did 2 units. But and then after she finished high school, she got a job in the tutoring company. So yeah, so I don't know. But anyway, and why do I do this? Because this guy becomes the ydx, and you know what, this guy becomes the vdx, etc. Okay, so read through the rest of the proof. I don't want to spend too much time because going through the proof doesn't help you to do the question. It just shows you where the formula comes from. That's all it does. Yeah. Okay. Read it later. Yeah. All right. I think I should move on because the main purpose of this exercise is to get you to know how to use it, how to do hard questions, not about the proof. Before, I spent 1 hour trying to understand the proof, and I still don't understand it. I waste so much time, but that's okay. This is just me. I just want to know everything, but that's okay. But you don't have to know that. You just have to get good marks. Yeah. Okay. Good. All right. Move on. All right. All right. So read the textbook later if you're really interested. Not that relevant, I don't think, in the syllabus. Okay, let's use it. Okay, want to see, okay, 2 methods. Obviously, we're going to expand this. Yes, you have the right to do so because it doesn't say which method. So you can go 6x squared minus 4x minus 9x, 9 plus 6, collect 9 terms. That's your y. And then do dy over dx, 12x minus 13. Right, pretty easy. Method 1. Method 2. Yeah. Unless the question say use product rule, otherwise you can use any method you like for this question. Any method. Method 2, let's use product rule. Y equal to 2x minus 3. That's where I have to use the product rule. And that's your U, that's your V. We're going to write down 2x minus 3, that's your U. Actually, write it here. U equal to 2x minus 3, V equal to 3x minus 2. Now, you may have learned that in tutoring, they will just do in one step. Yeah, you can do that. Once you know what to do, you can do in one step. But at this stage, do it like that because you break things down a bit, right? U dash is 2, V dash is 3, right? And then what you do is, why do I do it that way? Cross multiply. If you cross multiply, you can't get things wrong, right? Cross multiply. So easy. So Y dash is the cross multiply. U dash V plus UV dash. Remember, UV light, yeah? UV light, yeah. U dash V, 2 times V, 2 times 3x minus 2. And then notice I put 3 before the U because it's a one term, easier to read. And then you have to expand. And then go 6x minus 4 plus 6x minus 9. 12x minus 13. Exactly the same answer. You say, you're going to complain, oh my God, that rule is so long. Well, that rule is long for that, but if you choose the expansion method, it's going to be much longer for that one. So method 2 will be shorter. Method 2 will still be the same length for a hard question, but for expansion, you do have to expand longer. Does that make sense to you? So product rule is the way. Hopefully you understand why I teach product rule. People say, oh, it's so much longer, I could just expand. Yeah. Do you want to expand this? You're welcome to do that. And it's very likely you'll get it wrong. Okay, so we're going to do a hard question. So we've done a demonstration on quite a straightforward question. Now we're going to do a harder one. And not only that, not only have to differentiate, you have to find the value of x when the derivative is 0. So there's a lot of algebra involved. Make sure you pay full attention. So let's start. So we're going to have y equal to x, 3x minus 10 to the power 4. So we have u. I just let u to be the first guy, v to be the second guy. It makes no difference if you let u to be the second guy, you get the same answer. But just make it a rule for yourself, let u to be the first guy, v as the second guy. Yeah? Alright, so we're going to differentiate. U dash is easy, but v dash you have to do some work. What rule do you use? You have to use the chain rule. So Alex, P, can you tell me x comma? How do I differentiate? Yep, times by the derivative. Well done. Okay, make sure you simplify it. So that will be 12. Yep. And then once you set it like this, you can't miss the rule. Cross multiply. Get the idea? I mean, you can do it in one step. It's okay. But I used to do it in one step when I was high school. I don't do that. I only learned that method when I became a teacher. But if you have a tendency to forget, or if you keep thinking about how to play the game tonight, you will forget because your mind's always thinking about the game you're going to play. Then you may need this thing to as a extra insurance. Right, u dash v plus uv dash. All right, a break. For scientists, we are very professional. We don't do that. But this guy just like, I think he likes soccer. Maybe that's where he get it from. Okay, all right. So let's continue. U dash is 1 times 3x minus 10 to the power of 4 plus x v dash times 12 uv dash. Yeah. Okay, perfect. Now, usually you do not need to factorize. You can just leave it like that. That should be full marks as far as the question is concerned, right? That should be full mark. However, they want to find the value of x where the derivative is 0, when y dash is 0. Now you have to solve that. And to solve that equal to 0, you have to factorize. So normally you don't have to factorize, but for this question, you have to factorize. The question is, how do we factorize? Some of you can do it. Some of you may find it difficult. Watch this. Can be a bit difficult, but I should have chosen easy. Okay, doesn't matter. I'm going to do it this way. 3x minus 10. I'm doing the slow way deliberately so that people can see it. Some of you can see it, that's okay. But if you can't see it, do it the long way. Watch this. 12x. Running out of space. That's fine. It's about patience. We get there. Good. Now watch this. How many common factors? Use a green pen. That's common. 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 So 3 of them are common. So 3x minus 10 cubed, right? What's the leftovers? The leftover are this guy and this guy. 3x minus 10 plus 12x. Yeah? So I took the cube out. So you took the lowest common, select the lowest common denominator. You took the cube out. Hopefully that makes sense. Yeah? So if it doesn't make sense, just do it the long way. It's just longer, but you get it right. Yeah? But once you see it the long way, you should be able to do it the short way because your mind can imagine the abstract. Okay, we keep going. What's that? 3x minus 10 cubed, 15x minus 10. Yeah? Okay, we've got that done. And now we can answer the question, when is the derivative 0? Make it equal to 0. So we factorize in order to solve the equation. So let's factorize that. So we get, therefore, this thing is 3x minus 10 equal to 0. You don't have to worry about the cube because your cube root to 0 is 0. 15x minus 10 equal to 0. So it's actually a lot of work, a lot of algebra, as you can see. Right, we started with a straightforward example. Oh my God, I could do product rule. Yeah, that's good. Can you try a harder one? Well, it involves some work. Yeah, good. 10 over 3. And x is 10 over 15. 2 over 3. Okay, any question? Why don't you try the next one and see if you can work out. So you will learn a lot of algebra. You will develop a lot of algebraic skills in the calculus topic. You complement each other. You learn more algebra from calculus, and you need algebra to do calculus. So they complement each other. And now you see, oh, why is the teacher teach us factorization in year 9, year 8? When are you going to use it? Yeah, here, where you really need it. You go desperate when you need it. Okay, try the next one. Try the next one. Have a try. Product rule, and then solve it. Again, in order for you to develop this skill, you should immediately start the exercise after I finish. Right then, the teacher stopped talking. Now it's time for us to talk. No, seriously, if you finish it, you can go home, have a very good weekend. Have a good weekend because like you finish your homework, right? So yeah, good. Right, start now. Have a try. Have a try. And if you work out, you got to write. All right, we're going to have a try. So u equals to 2x minus 5 cubed. V equal to 3x minus 1. And of course, you can use Desmos to check that that's when the derivative 0. You can draw on Desmos. So it's very cool. During my days, I don't think internet just gets started. And I don't think there's a lot of graphing stuff. And then, oh yeah, there is a graphing calculator, but they're super expensive. So yeah, so it's not a lot of things. Yep, but yeah. Anyway, so to get started, U dash is chain rule. Notice I simplify it before I start using, right? I simplify 2 times 3. Don't leave it at 2 times 3. It's 6. You get the idea? And then cross multiply. How cool is that? Cross multiply. Who can't do that? You learned about cross multiplication in fraction. We can do that in here as well, and also in solving certain equations. Y dash is U dash V plus UV dash. U dash is 6 2x minus 5 square V 3x minus 1 power 4 plus U 2x minus 5 cubed. All right. Okay, now hopefully you can do it without doing the long way. Notice there's 2 common factors. There's the 6 and the 12. Take the 6 out. And then there's this guy. Now take the lowest one. These two, the lower one is 2x minus 5 squared. I'll do it in different color pen. These two, we take the lower one, which is 3x minus 1 cubed. All right, the harder bit is to write down what's the leftover. Look at each one. You check each one. Check the first one. 6 taken out, gone. 6 taken out, gone. This one guy left. Yes, one guy left because cube, compare cube with 4, one person left. Okay, plus, compare 6 with 12, there's 2 left, right? Compare this with that, cube, there's 2, one person left. These two completely taken out. And then you have to expand and collect like terms, which is 3x times that's 4x, 7x, minus 10 minus 11. So you have to concentrate. You have to think only about the work you're doing, not get distracted. You have to be very disciplined, not just disciplined physically, disciplined mentally, so that you can get this right. Again, you have to develop that as a habit. When you do the exam, it becomes easy. Yeah? And then we make that equal to 0. And that's easy now. So x equal to 5 over 2, 1 over 3, 11 over 7. Start the exercise today. Start now. Work hard now and laugh later. Because you'll be very happy. Yes, I got it right. Yes, I get good marks. Yes, it makes me happy. Yes, you will. Because you work far hard for it and you feel you deserve it. No one's going to say, oh, because you have this, you have that, you have tutor, you have blah. No, you work hard for it. Not because of lucky, not because of that, not because of anything. It's because you work hard. Good. Start now.